Let's see, so as we work with geometric sequences, we previously completed the arithmetic sequences, and arithmetic sequences were when we had a common difference. Something was being added or subtracted to create each additional term, and that was a common difference because it was the same change each interval. Well, what we're going to talk about now is geometric sequences, and the geometric sequences are going to be multiplication and division. So if something appears to look like multiplication or division, that's geometric. And really it's all multiplication, but sometimes when we divide by a number, it looks like division versus multiplying by a fraction. So all of those things, work together here to form this geometric sequence. We have talked about the explicit formulas, and what we have here is, if you look, this thing right here, that thing right there is going to be the explicit form of a geometric sequence. We've already covered the AN. The AN is some future number. We don't know what it is yet. A1 is going to be your first term in a sequence. Just taking a quick snapshot down here at number C, or letter C, the first term is going to be 2 to the third power. R is going to be my common ratio, and the common ratio is what is being multiplied or divided for each consecutive term, and then there's no change in N for its value. So as we come over here and we look at identifying a geometric sequence, we want to find out if it has a common ratio, and we have looked in the past and seen how to find a common difference, but to find a common ratio, we're going to take one term, some term, and divide it by the term before it. So in this case, if we look at your example here, what is the sequence? Is the sequence geometric? Well, if it has a common ratio, that means it's geometric. So if I take one term, if I take a 4 and divide it by 2, I get a 2. If I take 8 and divide it by 4, because 8 and 4 is its previous term, then I get a 2. So it appears to be a common ratio of 2. So is this sequence geometric? Yes, because it has a common ratio of 2. Looking at number 3, if I divide 5 by 1, I get 5. If I divide 9 by 5, I get 9 over 5. Well, that tells me right there, these two things are not the same. Therefore, we do not have a common ratio. So it is not geometric. Looking at letter C, we can go ahead and take a to the 7th divided by a to the 3rd, and it turns out when we do our exponent rules, we find out that is 2 to the 4th. Then if we take the next term, term 3, and divide it by term 2, then we get again x to the 4th. So those two are the same, so we do have a common ratio, and that common ratio is going to be 2 to the 4th. And let's see here, so now that we have identified geometric sequences, let's try to analyze these geometric sequences. So what is the second term of the geometric sequence? 3 and a blank and 12. Well, I'm trying to find the geometric term, and what I can do, there's multiple ways to do this actually, but what they're trying to get us to do is use some of our information. So we have our formula, the explicit formula, and we know that we need to find some term, we need to identify our first term, we need to identify our ratio. And in this case, we are given the second term of a geometric sequence. What is the second term? Well, we know the third term, we know the first term, so we can use that to identify what our common ratio is. And once we do that, then we can go on and do more. And I can turn around and say, okay, well, 12. 12 is A3, so I can replace AN with A3. A3 equals A1 times R to the 3 minus 1. Well, we don't know what R is yet. But we do know what A is. A1 is going to be 3. So we can go ahead and simplify here. I know A3 is 12, so I've done some substitution here. A3 is going to be 12, and it is going to be equal to A1 is 3, 3r squared. I'm going to divide both sides by 3. And then that way I get 4 equals r squared, or when we find the square root of r squared equals the square root of 4 squared, so then r equals 2. So if my common ratio is 2, well, plug that back into my equation right over here, and it's going to turn out that that number is going to be 6. There you go. There you have it, analyzing a geometric sequence. And here, if we wanted to find out what is the third and fourth terms of a geometric sequence, well, we can do the same thing. We are going to use this a to the fourth, and I know that when I look for when I'm using my explicit formula, I need to find an. Well, an is going to be a to the fourth. Okay, we're going to use that value. We know what a1 is. That is going to be 2. We don't know what our ratio is yet, but we do know still the n. The n is valued at 4 minus 1 versus n minus 1. So now we simplify. I've replaced here. Well, we know that a4 accounts for 128, so we've done a substitution here. Substitution, that was some of the given information. We can divide both sides by 2 to get rid of this coefficient right here. So we can divide that, and then we end up getting 64 equals r squared. 64 equals r cubed. Now once I have r cubed, I can go ahead and find the cube root of both sides. Cube root of 64 is going to be 4. Cube root of r cubed is going to be r. So I know my common ratio is 4. Coming back over to my problem, I can substitute that information in to get my next two terms.